You're listening to AI Podcast. I'm Ethan, and today we're unpacking a paper called Voyager, an open-ended, embodied agent that learns to play Minecraft by writing and improving its own code. The quick takeaway is this: Voyager proposes its own tasks, turns successful behaviors into reusable programs, and keeps refining them with feedback and self-checks. In comparisons, it collected roughly 3 times more unique items, traveled over twice as far, and reached key tech tree milestones up to about 15 times faster than comparable language model agent baselines.
Clear and to the point. Who led the work?
The representative authors are Guanzhi Wang and Yuqi Shi, with senior guidance from Lingxi Fan and Anima Anand Kumar. The collaboration spans NVIDIA, Caltech, UT Austin, Stanford, and UW-Madison. The team also released a project site and code so others can inspect prompts and implementation.
All right. What gap are they trying to close in plain language?
The big challenge is lifelong learning in open-ended worlds. Traditional reinforcement and imitation learning often act at joystick-level controls, which makes long, multi-step exploration and reuse of skills hard. Recent language model agents can plan, but they usually don't accumulate a toolbox of skills that compounds over time. Voyager targets that gap: an agent that proposes what to learn next, learns it as code, and remembers it for later use.
So it's trying to teach itself rather than just follow a script. How does it actually work?
They make one key design choice: treat code as the action space. The system has 3 parts. First, an automatic curriculum uses a language model to suggest the next achievable, diverse task based on the agent's current state. Second, a skill library stores verified, named programs, little functions for things like crafting tools or fighting a monster, that can be retrieved and composed. Third, an iterative loop runs the code, reads feedback from the environment and any interpreter errors, and uses a separate critic step to decide whether the task really succeeded before saving the skill.
Right, and using programs means you can chain them. Why is that helpful in practice?
Programs naturally capture extended actions and can be reused. If you've written a reliable gatherwood skill, you can reuse it inside craft a pickaxe, and both of those inside mine iron. That composability, plus the curriculum and the self-verification, helps the agent move steadily from easy tasks to harder ones without forgetting what it learned.
Got it. What did the experiments look like?
The agent runs in Mine Dojo and controls Minecraft through the MineFlayer Code API. GPT-4 handles code generation and self-verification, GPT 3.5 helps with lighter language utilities, and embedding supports skill retrieval. Temperatures are set to 0 for stability, except a small bump for the curriculum to keep ideas varied. For comparisons, they adapted React, Reflection, and an auto-GPT-style setup to the same setting. They evaluated exploration, progress through the Minecraft tech tree, map coverage, and transfer to fresh worlds on unseen tasks. Budgets were counted in prompting iterations rather than wall clock time. Exploration and tech tree mastery used a fixed iteration budget, and zero-shot tasks like crafting a diamond pickaxe or a compass had a 50 iteration cap. Each condition ran 3 trials.
So everyone got the same signals and budgets. Voyager just had that curriculum and the skill memory.
Exactly. Voyager discovered more than 60 unique items within the fixed budget, reached higher tiers of the tech tree more quickly. Importantly, it was the only one to reach diamond tools in that setup, and covered a lot more ground on the map. When they reset to a brand new world, Voyager's stored skills transferred. It solved the unseen tasks within the cap, while the baselines didn't. A nice detail is that even the Auto-GPT baseline improved when it was allowed to use Voyager's skill library, suggesting the library is a plug-and-play asset.
That transfer point feels important. It's closer to real learning if skills survive a reset.
Right. The ablations also show which parts matter. Replacing the automatic curriculum slowed progress because the agent tried tasks in a poor order. Removing the skill library caused plateaus later on. Taking out self-verification hurt the most among the feedback components, because it decides when to move on versus retry. And swapping GPT-4 for GPT 3.5 degraded code generation and downstream performance.
Let's sanity check. What should listeners be cautious about?
First, many results are averages over 3 runs. That's common in interactive agent work, but still a small sample. Second, the system depends on specific API versions and prompt designs, so results may shift as models change or if costs push different choices. Third, they intentionally didn't compare to pixel-to-control agents because Voyager acts through a code API. It tackles a different slice of the problem. And finally, the authors note limits: GPT-4 cost, occasional hallucinations like calling non-existent items, and occasional misses by the self-verification step.
Makes sense. If you had to sum up the contribution in one line, what would it be?
A practical recipe for compounding capability in open-ended worlds. Use a language model to write modular skills as code, keep a memory of what works, and guide the process with an automatic curriculum and a critic so the agent keeps improving and the skills transfer to new settings.
And what should researchers try next?
3 ideas. Bring in vision so the agent can reason over pixels, not just text-level state. Connect high-level program synthesis to learned low-level controllers to bridge perception and action when there isn't a friendly API, and improve rigor and efficiency with more trials, varied world seeds, and cheaper or distilled models so results are easier to reproduce.
All right, measured, practical, and forward-looking. Thanks, Ethan.
Thanks, Maya. This has been AI Podcast. If you want to explore the details or the code they used, check the paper and the project site. See you next time.